Hello students, welcome to online lecture series of discrete mathematics. Today we start with our next chapter, that is tree, right? So what is a tree? Generally tree is a type of a graph. What is tree is a type of a graph, or when we consider a general tree, so a graph which has a no cycle is called an acyclic graph. A tree is an acyclic graph, or we can say a graph having a no cycles. A tree or general trees is defined as the non-empty finite set of elements called the vertices or nodes, having the property that each node can have a minimum degrees 1 and maximum degrees n. It can be partitioned into n plus 1 disjoint subset such that the first subset contains the root of the tree and remaining n subset includes the elements of n subtree. Directed trees. A directed tree is an acyclic directed graph. So here, node which have out degree, the node which have out degree greater than or equal to 1 is called as an internal node. Okay? Or a node which has an internal degree, or a node which have out degree greater than or equal to 1 is called as an internal node, right? And the node which has an incoming degree 0 is called as a root node. Properties of trees. There is only one path between each pair of vertices of tree. If a graph G, there is one and only one path between each pair of vertices G is a tree. A tree T with n vertices has n minus 1 edges. The next property, a graph is a tree if and only if it is a minimal connected. So what is the rooted trees? If a directed tree has exactly one node or vertex called a root whose incoming degree is 0 and all other vertices have an incoming degree 1, then the tree is called as a rooted tree. So you have to note 2 points here. First, a tree with node is a rooted tree, and a single node with no children is also a rooted tree. So this is your a tree with a root node and internal nodes and the leaf nodes. Path length of a vertex. So path length of a vertex in a rooted tree is defined to be a number of edges in the path from the root to the vertex. So we'll see the example. So here, find the path length of the nodes B, F, L, Q as shown. Right. So here we find out the path for each and every node here. Suppose so we have to find out the path length for this B. So as per the definition, so number of edges in the path from a root to the vertex. So which one is root here? This A is your root. So here we have to find out the path length of this B. So there is a distance of number of edges from root node to B. How many edges? That is 1. So this path length of B is 1. Second, path length of F. So path length of F. So this is your F, right? So number of edges from root node to that F, that is 1, 2. So path length of node F is 2. Next, that is L. So this L. So path length of L from root node to, that is from A to L. So number of edges 1, 2, and this one is 3. So path length of node L is 3. Next, Q. So this is a Q. So path length from A, root node A to this Q. So you have to find out the number of edges. So this is 1, 2, 3, and 4. So 1, 2, 3, 4. So number of edges are 4. So path length of node Q is 4. Again, to find out, suppose you have to find out the path length for this K, right? So for this K, 1, 2, 3. So path length for K is 3. Again, same for N. So 1, 2, 3. So this is a 3. Path length of N is 3. For G, 1, 2. So path length for G is 2. For path length for M, 1, 2, 3. So path length for M is 3. So this is a path length, that is in rotating. That is the number of edges in the path from root to the that vertex.